Okay, I'm going to give you the following objective. Exponent more complex rules and introduction to polynomials. This you have as also learning system, polynomials. Okay. But first I'm going to finalize to talk briefly about complex rules of the exponent. This is the product of two variables, right? Look, if I raise this product to the power of n, and this rule, this is more complex rule. This rule simply saying that if you have the product, we have here two factors, or two multipliers, or two variables. So that is, according to this rule, you have to raise to the power of n each factor. Since we have here two factors, right? So that means we have to raise the first factor to the power of n as well as the second factor to the power of n. So, do you see? This is the rule. Actually, this is the formula. This is identity. So that means we have the right-hand side and left-hand side. They are identical. So that means if you have a problem where you are supposed to simplify, and this is given to you in the board like this right-hand side, so you may simplify it using the left-hand side. Or if this product is given to you and you need to simplify and further to make your computation, right, to get numerical answer, so you can use the right-hand side formula. I'm going to give you an example. Like, for instance, 10x to the second power multiply 10x to the second power raised to the second power. So left-hand side of this identity. So according to this rule, I can write it as it is. The first factor is 10 itself, right? 10 to the second power, and then the second factor is variable. X to the second power raised to the second power. And you already know this rule. This is power to power rule, right? If you are raising power to the second power, so that means you have to multiply the exponent, correct? And 10 to the second power, this is simple computation, right? This gives us 100, right? So what we have? 100 to the fourth power, correct? So in terms of the, if I put my objective like the first objective like more complex exponent rule, So in terms of the complexity, I wouldn't define this rule as a complex rule, right? So that means the complexity here, that means we are applying the exponent rule for each variable, but in fact we have a product, right? So now, how about if I write the question a over b raised to the power of n. So according to this, if we extend this rule, the product rule, and since the question division is the inverse operation, right? So we can extend this rule and write that this question rule this is rational expression actually itself, right? Division, right? So if this rational expression raised to the power of n, so I can write it as it is bar, numerator raised to the power of n, and denominator raised to the power of n. And since here we are dealing with the variable, and variable, it can be any real number, right? So that means we have to put a restriction here that b is not equal to 0, right? If b is equal to 0, so what could be happen to our rational expression? We cannot divide by 0, right? And how about this? Look, an example I can give it to you. Like 2 over a cubed raised.
They can't see because the podium.
I can put this example. Right. 2 over a cubed raised to the 5th power, right? So what happens? Well, how we can apply this rule? So that means, look, the top numerator raised to the 5th power, that means 2 to the 5th power, and denominator is a cubed to the 5th power. A cubed to the 5th power, 2 to the 5th power, that means 2 multiplied by 2, 5 times, right? 2 multiplied by 2, by 2, by 2, 5 times, gives us what? 32, right? 2 to the 4th power is 16. Remember this always. So that means this is like a fixed point. So that means 60 multiplied by 2 gives you 32. 2 to the 6th power gives you 64. 2 to the 7th power gives you 128. 2 to the 8th power gives you 256, and so on. So that means it's like 3 term for you. 2 to the 4th power. Remember, this forever. This 60. And from that fixed point, you can make all your computations, right? So this is 32. And how about this? Denominator part. This is power a to the 15. This is, we are applying here the exponent rule, power rule. So that means we have to multiply the exponent. A to the 15. And how about one more rule? This is the third rule. A over b is the exponent of negative 10. Look, we have the following rule. Look, if we have here negative n, right? Negative n. So based on this rule, what I'm supposed to write? A is the exponent of negative n, right? And b is the exponent negative n. But a negative exponent gives you what? You can write this as the positive exponent. How? On the top, what we have? 1 over a is the exponent of n, right? This is, we change this to the positive. So the positive exponent rule says this is immediately you can write as a rational expression. Numerator always 1. And denominator, the same power, the same base, only exponent is positive, right? So, remember this, always, right? So, and b with negative n exponent also gives you 1 over b with the exponent n as positive, right? So, this is clumsy construction, right? So, I can write this division as it is. So I'm going to put here arrow 1 over a is the exponent of n divided by 1 over b is the exponent of n. And here what we are supposed to do? Just do cross multiply, right? So what we have? B with the exponent of n, A over A with the exponent of n. So what happened to this formula? So look, we derive brand new formula. So immediately you can write A over B with the exponent of n. Negative n is equal to what? B n A with the exponent n, or B over A to the power of n. So immediately, look, you can write that A over B with the exponent negative n. You can flip inside expression, inside rational expression, flip this rational expression or algebra expression upside down, right? Denominator becomes numerator, numerator becomes denominator, and raised to the power positive exponent of n. I'm going to give you one more example. Do you see? Huh? F to the 4th over y to the 5th with the exponent negative 3. So this is for me A, and this is for me B, right? This is negative 3 exponent. So based on this rule, this is, by the way, the number 4 rule for today. So I'm going to rewrite this. I'm going to, inside the expression, flip this rational expression upside down. Denominator becomes numerator. Numerator is going to be denominator, and write this with positive exponent, right? Y to the 5th, A to the 4th, raised to positive 3 exponent. And now I'm going to apply power to power rule for each one, for numerator and denominator, right? So what we have on the top, y with the exponent 15, what? 5 times 3 gives me 15, right? And on the bottom we have x to the 4, 4 times 3. Is it helpful for you? So today, look, we got 4 more complex rules. Complex rules, if we are talking about complex rules, that means complexity, right? Like sophisticated formula. But I don't see here any sophistication, right? It's simple. Only what we did based on what, the